Welcome to our webinar, The Hidden Cost of Variability in Mineral Processing. It is a pleasure to be here with you once again, this time talking about real-time process optimization and unlocking the true potential of your operations. Well, in case you don't know me, nice to meet you. I am Nathan Taide Bonfim. I am the technical leader of automation here at AVEVA Select Brazil. Today, I am responsible for our information and data analytics portfolio here at AVEVA's portfolio. And today, I have a very special guest who will be here with me during this webinar to talk about Braincube. Rafael Barros will be here with us. He will introduce himself shortly. And speaking a little more about AVEVA Select Brazil, in case you don't know us, we are AVEVA Select Brazil. We are responsible here for the entire AVEVA portfolio here in Brazil. We are here, we work with pre-sales, sales, we have our technical support team for the AVEVA portfolio, we provide training on the tools in our portfolio, and we also have a consultancy catalog with more personalized services in our portfolio. And over the years, we have been awarded as one of the most important partners globally among all AVEVA partners, and we have been awarded, we won this award, right, for 3 years here. Well, folks, it's very important to highlight here as well. If you have any questions during our webinar, use the chat on our platform, post your question, and if you're not seeing our questions, just press F5 on the page and you'll be able to see your question. But throughout the presentation, we will have a moment to address your questions and we will be discussing them here. Well, to talk about AVEVA's portfolio, we could spend the entire webinar discussing the portfolio. It's immense. So I will mention some software that you may have already heard of, and it's quite interesting for you to know about them as well. In the SCADA part of our portfolio, we have our AVEVA Edge, also known as Indusoft, our plant SCADA, formerly Cytec, formerly Visual Cytec as well, the famous InTouch HMI from our Wonderware software family. We also have our system platform, formerly Orchestra, formerly IAS. For the data historization part, we have our AVEVA Historian, formerly InCycle, also formerly from our Wonderware software family. To talk about industrial reports, we have our very simple tool for building our industrial reports with reports for operations, or the former Dream report. For our PIMs, we have our PI system with over 40 years in the market from the former Ossisoft. For batch production management, we have our batch management, the former InBatch, our model-driven MS, and our production management, the AMPL, aimed at continuous manufacturing. For our data analytics software, we start thinking about predictive chimia. We start thinking about cloud. We have our predictive analytics, advanced analytics with predictive, and our Connect, our cloud SaaS platform. Well, and AVEVA Select Brazil has further expanded our software catalog now with partners. And all these partners that I will mention here are certified partners of AVEVA. So software focused on data analytics. We will talk a lot in this webinar about Braincube, mainly aimed at the name production optimization. We also have our times here focused on data cleaning and treatment, mainly concentrating on the fidelity of this data. For asset management, we have our AMDT, the old and very famous autosave and version dog, mainly focused on versioning and backup of applications. Today known as Octoplant, we also have our CMMS, our maintenance management software with Limbo. Focused on communication and security, we have here Skynet's Cogent Data Hub and our Toolbox software. Well, folks, it is with great pleasure that I bring Rafael here with us, who will be participating with us during our webinar. Please, Rafael, welcome.
Thank you, Nathan. Good afternoon, everyone. Thank you for being here. I am Rafael Barros, Director of Operations and Technology for Latin America here at Braincube.
Braincube is a French company founded in 2007, and today we are present in more than 250 industrial clients around the world. And our purpose is simple: to transform data that the industry already generates into practical decisions for operation. And today I will talk about a topic that affects each of your operations every day and costs much more than most imagine.
Today we are going to talk a little more about variability.
So I will use this GPS driving analogy throughout our conversation today. And I wanted to understand from you, how do you conduct the processes today? How do you determine the best route to follow considering the current conditions? And how do you adjust the routes when these conditions change? I brought 3 examples here that I would like you to type in the chats. First option, asking for information along the way, looking at signs, trying to understand if you're going in the right direction or not. Then consulting maps, checking the possible paths, the possible routes to reach the destination. Or use a GPS, a more automatic system to direct the best route. I would like to ask you to type here in the chat so we can understand how the audience is throughout the presentation. So to start talking about variability, I think it's important to define what variability is, right? So variability is the silent enemy of industrial performance. It is the unwanted fluctuation of key process parameters around an optimal point. When we look at complex environments like mining, it is interesting to separate these key parameters into 2 groups. So into control parameters, where we have valve position, motor rotation, dosing flow, temperature, and also the other parameters, which are the conditions, those we do not control. The raw material there, the iron content, the energy price, environmental conditions. Sometimes there are processes that rain impacts a lot, right? And market demand, right? So let's move on. And variability, it is inherent to the process, to any industrial process, because the process is never static. So the composition of the ore will always change with each mining front. The process conditions will fluctuate continuously, and the equipment will degrade over time. So we never have a static condition where it is possible to master the stability of that process. And then, as a consequence, we observe a more conservative behavior in the operation. And any of these key conditions change, this causes variability in the process. There is a tendency to operate with more fixed, safer set points until understanding what is actually happening.
And question I have here, Rafael, when we talk about variability, can we understand it as a defect, as some operational failure? Because when we talk about mining, the ore will naturally change with each extraction. It comes from nature in different forms, right? So wouldn't that be normal?
It's an interesting point, Tantan. I wouldn't consider variability as a defect because it will always exist, right? So it won't be something occasional. What happens is higher or lower levels of variability, which then, especially in mining, will depend a lot on the quality, the condition of the ore. I think the important point is not to consider it as a defect, as a reality where nothing can be done because there is a lot to do. And for me, this is the starting point to try to reduce this impact of variability. So I would say not to consider it as a defect, but to consider it as an inherent characteristic, as there are processes that will vary more than others.
Not accepting the state, right? But something natural from the operation itself. Perfect, thank you.
Exactly. And as I said, every process varies and we have 2 choices. So either we absorb this variation in the production cost or we absorb it in the final product. In the production cost, whether by dosing more certain chemicals, operating in a slower manner, the line speed, or it will be absorbed in the final product. So depending on the final product, you have sales tiers. You will always focus on the best quality standard, on the best specifications that the customer is looking for. But eventually your process will vary, you'll lose control there, and it will end up your final product may end up being disqualified in relation to that quality level, leading to a sale to a secondary market that will pay less. How it's one of the hidden costs of process variability. And then I usually say that the amount of money you will lose or gain depends on how you control the variability. And then in the next slide, I brought some numbers to better illustrate this issue of this hidden cost, right? We don't have a variability indicator in the monthly report there to monitor. It's something that's much more hidden in the operations. And doing a general survey with our clients, we see that typically between 10% to 20% of the annual revenue ends up being lost due to variability. Part of this variability is actionable, right? Part of it really can't be helped, but I think it's important to focus on the part where action can be taken. And here I brought some examples, right, of loss in metallurgical recovery due to variability, losing from 3% to 5% of revenue, reagent consumption, and also loss of capacity. And then you can notice that these are small indicators, 1%, 2%, 3%. But when you start adding this up and have a monthly recurrence of these costs that everyone considers as part of it, at the end of the year, you left a lot of money on the table. And I will bring an example from one of our mining clients just those numbers there on the side. When we started working with them, it was something around 50,000 per day, a very large operation. 50,000 per day in production loss. And there we are considering excessive consumption of chemicals, etc. And also loss of capacity. They were supposed to be producing at a certain pace and they faced the constant reduction of that pace. No one could explain or control it. Of course, there were initiatives to address these problems, but when you looked at the long term, there was no explanation. It was simply, no, my process varies, the mining operations are varying a lot, the quality of what I'm receiving is varying a lot, so my costs will vary a lot too. It was kind of part of the process, right? So the biggest problem isn't the loss itself, but the fact that this loss will be hidden and will give a sense of control of if I can't do anything, I am already controlling what I can do. What we will see in practice is that there is a lot of room to work with.
And a question actually, when we talk about 10 and 20%, it's a lot of money, especially when we have this example of 50,000 per day, right? So even for those who are watching us who might be facing the same problems, what is preventing these companies today from pursuing this? What is preventing them from finding this reduction in variability today?
Great. I think it's not preventing. In fact, I would like to ask the audience if they could type in our chat so we can talk later about what you see in your operations nowadays that is being done to combat variability, right? To combat that cost that keeps fluctuating throughout the month. But responding to your point, Nathan, I think we will even address some of this throughout the meeting. I see that everyone is taking action. The current market condition, the economic scenario here, especially in Brazil, is not allowing for, well, losing 5 or 10% because my process is varying. I think the demands have increased a lot about what is being done to recover this money. And I see that the main limitation, the ceiling we see, especially in mining, is the speed of reaction, right? I'll move this topic forward a bit more, but I would say this. I would say that we notice that no one is idle anymore. And what we encounter more is the difficulty of how to proceed more effectively in this.
Perfect. Thank you, Tawfik. Thank you. And following up on your point, folks, if you want to put it here in the chat, it's anonymous, so the chat is just for you, okay? And if you don't see your question, just refresh the page and you'll be able to see it, okay? Let's go.
Well, now that we have clearly defined what variability is, I'll move on to the next point, which is how we identify variability. There are various tools to evaluate it. I brought one here that I really like, which are the 6 M's, the basis of Ishikawa. And then I brought it here with examples that we usually see, quite common in mining.
So first point, identify my root cause hypotheses that are generating this variability in my process. And here I brought a common example, which is labor.
Operator A doses 150 grams per ton of reagent. Operator B doses 130 grams per ton of the same reagent under the same condition. Why? There is no defined criterion. There's the weight of experience. So there's this line of, oh, I'll dose between 130 and 150 because it will be effective.
But what is the reality? How much do we actually need to dose now to achieve cost effectiveness? And mainly, how is this reacting throughout the process? Is this generating a chain variability with other parts of the process?
Yes, and then we make a link to the other M, which is method, because if there are no adaptive recipes for the conditions in the process, there will be variability. We commonly find standardized procedures, mainly focused more on safety, both for people and assets. So limits that you should not exceed. But commonly there is this gap of, if I have a different characteristic of my ore, what condition should I operate in? How should my flotation process react to the cyclone, etc.? Yes, and then a lot of weight is placed on the operator's experience, which is extremely important, but we also cannot place all the responsibility and blame on the operator for micromanaging the process. Another point to bring up, also quite common in mining, is the M for measurement. It is common to find measurement processes where sensors do not yet exist. So you need to take laboratory samples, and sometimes the processing time is very long. And while waiting for the result of this laboratory test, we revert to the operation behavior of holding back. I adjusted my process, and until I have the laboratory result, I'm going to hold back the accelerator here to understand what's happening. And in the next slide, to illustrate this a bit more, I brought another recommended step. So we understand here what the root cause is. It's an exercise that probably all of you here in the audience do at your company. So there's the mapping of root causes. And I brought here an example of what to do now. So generally, a statistical process control is used, and there are infinite tools to do this. I brought the example here of a control chart, right? The X bar and the MR. Work on a historical collection of how these critical variables that were mapped are behaving. And this method will indicate when it goes out of control, right? It will detect variability after it occurs. It is not a preventive method. It is very good for generating a reactive action plan, and it is also very good for helping with prioritization. Many times we hypothesize in the 6M stage, the root cause, when we look at the data, they are not showing this well. They are showing that it is not varying much there. And then this indicates that maybe we didn't hit the root cause itself, so we need to look for other sources. Yeah. I won't go on here. I'm illustrating with statistical examples. I believe that a good part of the audience already has this in their daily routine, right? Statistical control. Even if you could also comment, what kind of statistical process control do you usually use in your daily routine? Yeah, but I wanted to illustrate more this sequence of how we can actually identify the variability. And then identifying the variability, the next step is how I can act on the variability of my process. Now that I know it exists, I know its weight, how can I act on it? And here I return again to my initial example of driving, right? Driving the car. And even Nathan, I don't know if you have the results of what people commented in the chat, what they identified more with, how they are guiding the processes today.
Yes, I do. I saw here that some people even mentioned Waze, mainly for transportation, but I also saw some people here saying they use GPS today in production, but also still use maps.
Okay, cool. So I'm going to ground this example here about asking for information, consulting a map, or following the GPS. And to illustrate, I'll use this client of ours again.
He had a problem, a very, very serious objective of improving metallurgical recovery in flotation in an environment where there was a large variability in ore conditions. So let's go through the slides here that I will be illustrating.
So first step, how can I act on variability? The first step is to seek information along the way. The road signs, right, are reactive monitoring. And then translating this to the industrial environment, we see a lot of statistical process control itself and dashboards there in real time. It will show on the GPS, it will show if you got the path right or wrong, but it won't tell you the correct route. So if you take a road without a map, without GPS to a new path, you go slower, observing the signs to understand if you are indeed on the right path. And then when you are on the right path, you can speed up. But while there is no certainty, the idea is to move a little slower. So it's a great way to prioritize and direct the operation. It's a more reactive approach, right? With a conservative tendency. Yes, however, it requires constant checking and analysis of the information. Here, a common tool we see is Minitab, Power BI, even a good part of AVEVA's tools that allow the operation to monitor in real time what is happening. And this is already a very good step. Having this reactive monitoring of the industrial reality already increases the gain by 15 to 20% in the reduction of controllable variability. So if we compare an operation that runs blindly, let's say, with an operation that already has some maturity in reactive monitoring, you can clearly cut those 15%, 20% of variability. And then as an example of this client, it is wait for the slide to load here. He was already doing this. He had been doing this for some time. It was even quite mature in the matter of reactive monitoring, but there was a very serious problem that he faced almost daily there, the issue of laboratory sampling. So I even brought an example here of what was happening. So the operator detected that something unusual was happening in the process. It wasn't reacting the way it was supposed to. They requested a sample collection of concentrate at some points in the line. So for example, at 10:30. The laboratory took a while. The result would arrive around noon, an hour and a half later, indicating that the metallurgical recovery was 82%, below the target of 85, and the silica concentration was above the limit. So he understood, okay, this is my view, this is my board, I need to adjust my process for this condition. And then the operator adjusted the parameters at 12:15, increased the dosage of collector, corrected pH, etc. Based on his experience of what needed to be done in the situation, he requested a new sample collection that would be ready around 2 o'clock in the afternoon, which confirmed the improvement that indeed he made the decision, the effective decision. And then the recovery went back to 86%.
And then he was confident to, let's say, speed up and continue by increasing the process capacity. However, 2 hours of production were lost there. Reduced production, kept production at a reduced level for 2 hours. And besides the extra cost of the reagent, he didn't necessarily dose the effective amount. He dosed what he thought would be ideal for that moment. So a very common scenario. And then we move to the second point, which is the maps.
So in my analogy of driving, I brought up maps as the static analysis of the process, right? They are the pre-programmed routes. You look at your path before leaving home. It will work as long as road conditions don't change, as long as a tree doesn't fall on the way, etc. That route you programmed will be effective, right? And here in my example are structured continuous improvement projects, Six Sigma, DMake. Also quite common is the issue of data analysis, projects driven by data science, which focus on finding the root causes of the problem occurring in the process. It follows a standard framework for investigating processes through data. It identifies the parameters with the greatest impact and then defining new control set points. It's an approach that generates deep knowledge, but it's specific. That insight is valid for the study condition. When the conditions change, it starts to degrade. And we have what the sawtooth effect. You implement a project, do a green belt project, achieve great results. And after a while, it starts degrading, and then you need to do a new project.
It is extremely effective, but it depends a lot on specialists. You need to have good professionals like green belts, data scientists, and engineers with a lot of experience who may not always be available at that moment to do this, and it is time consuming. These are projects that sometimes a green belt project will take 6 months to actually achieve effectiveness.
Yeah, and it brings returns, right? We can observe there 35 to 50% of reduction in this variability of the process, especially when you have effective work there from a green belt, identifying the root cause. Yes, but the toll you pay is when conditions change, you will have to redo the entire process. And then I brought the example that was exactly the moment we entered with this client. So they had run a Six Sigma project, a very extensive analysis of 6 months of historical data on flotation. They identified some factors there in the collector dosage, pull pH, silica concentration that were explaining 48% of the variation in metallurgical recovery. So they did a design of experiments with the engineering team, managed to determine what the parameterization would be, the set points of the prioritized parameters, implemented these set points as the operational standard, and the result was practically immediate, right? The recovery went up from 84 to 86 in the first weeks. The team celebrated, it was extremely effective, but 6 months later, there was a big change in the mining front. The ore had characteristics quite different from what they had analyzed in this process, in this project, and the set points of the project were no longer as effective, and the gains started to degrade. So that's exactly where we came in, because it was unsustainable to have to run projects on top of projects for each change in mining. And we started to have this action there with the GPS.
And then in my analogy, what I brought as GPS is the issue of dynamic process parameters. You need to have adaptability in your process parameters. And in the case of Braincube, what we offer is AI-driven RTPO, which is real-time process optimization,
which would be a GPS that recommends in real time what you should do in that situation. But in fact, the one driving is you. The one driving is the operator. He has the view of the road. He sees that if the GPS is telling me to turn right and there's a fallen tree on the right, I won't turn. There is some contextual information that is not included there, So I will move forward. It will recalculate the route, suggesting to me, if I didn't turn right now, what I need to do further ahead. So these are analytical models that evaluate the current conditions of the process and will prescribe the best operational windows in real time. The operator will receive this recommendation live and will evaluate with his experience and practical field vision if it applies at that moment. So this is exactly what Braincube does today with RTPO. It is a system focused on delivering continuous and dynamic prescriptions based on the plant's history, not just theoretical computational models. Yeah, and here we can see another level. We can clearly see up to 85% improvement in variability, not because it's AI, not because it's a black box, but for me, the root cause is in the consistency of its application. And then in the next slide, I have the example of this client's performance. So we divide it here into four pillars. First is the analysis. We have the cross-rank AI system analyzing. In their case, it was 600 variables, around 600 controllable and uncontrollable variables. So there is this analysis of the process reality of the variables combined with the input that engineers and analysts provide about the business rules. So you have this analysis construction by the cross-rank model in partnership with the engineering team, always based on the process reality, always based on the conditions that the process actually followed over time. And and we move to the second pillar, which is the prescription of the operating windows for each parameter of the chart. So the system selects at that moment, in that current condition, which parameters should be adjusted, which are different from a set point calculated based on the history.
The operator has that really like a GPS saying to turn right. I should turn right now.
And then we have the execution step, which is really this live aspect where the operator has access to this information. It's not a black box. They really need to understand why the system is prescribing that. They need to have the autonomy to decide that if, for example, there is maintenance work being done on the line and the system is asking me to increase the speed, I cannot do that. There is no context variable indicating that the maintenance team is on the line. So the operator's autonomy needs to prevail there, and he should hold the speed. After the maintenance team leaves, okay, what is the GPS telling me to do now? Is it really to increase the line speed? So let's do this. And we have the fourth pillar of learning. Yeah, for me, one of the most important, which is the issue of self-training. As the operation applies the prescriptions, as the engineering team adjusts the business rules in the model, it learns from the results and becomes increasingly effective. And in parallel to this, we also have the platform for application and result management, more focused on coordination and management to understand if when the operation is actually following the prescriptions, we are having an effective impact on the results. If yes, we will encourage this greater application. If not, we will adjust, we will understand what the model is not considering, if there is any business rule we left out, if there is any sensor that is not being considered, and then perform this constant cycle. And here I brought some results they achieved. So 7 million in annual gains through these prescriptions, a return on investment of 12 times, much higher than they were expecting at the beginning of the project. And then for me, one of the main ones, a 2.4% constant increase in metallurgical recovery. The issue of consistency is very important. It's no use having a peak improvement of 5% and then the following week you have a dip of, I don't know, minus 10%. So this consistency is very important, and having this system guiding helps the operator maintain this consistency.
Rafael, these numbers are very impressive. And the question I have, which I imagine many people might also have, is how long does it take to implement a solution like this? Are we talking about months? Are we talking about years? So what is it?
Great.
I see that when we are talking about RTPO at Braincube, we aim for projects that are extremely goal focused so that we have a clear view of the scope to act, to break that tendency of having to do everything, having to look for causes in the entire process. We have a very strong consulting team to guide these scopes for action.
And then from 8 to 12 weeks for the implementation process, reaching the go live at the end of this 8 to 12 weeks, with the go live being the practice of GPS. And from there, it's the application of the operation and adding up the daily results. How much are we avoiding losing? How much are we gaining with this fight against variability?
So
these are short projects focused there. And what we usually see is, let's say, a fitting of pieces, a fitting of this puzzle, where the client starts with one objective, reaches that operational maturity, then adds another objective, then another objective, and these objectives start interacting with each other.
So there are clients who prefer this approach of constant building. That's why we need to be very lean about it and focus on 8 to 12 weeks of implementation.
How interesting. Thank you, Raphael. Taking advantage of the hook here, folks, for those who didn't see it at the beginning of our presentation, we will have a raffle at the end of our webinar, so stay with us until the end. If you have any questions, send them here in our chat. It is anonymous. So we will select some questions here at the end, and we will be answering them at the end of our presentation, okay? Thank you, Raphael. Let's go.
Let's go. So I brought this slide here to close this analogy of the GPS with the RTPO, because what does the GPS actually do in our daily lives?
So it evaluates the current conditions, considers the traffic, if there is construction, an accident, a traffic jam, compares with the historical routes that worked, and it will calculate the best route for now and will recalculate as I adjust or as the traffic conditions there change. The RTPO does exactly that in the process environment. So it will evaluate the current conditions, raw material, temperature, environment, various conditions that impact. It will compare via model with the proven historical performance and will calculate the best action windows for now, for the current condition of the moment. And as the operation continues or not, it will adjust its recommendations.
And also, right, when we talk about GPS, when we talk about car GPS, right, we have a path there. We can see the path. It's very clear. And how do we see this GPS? How does the operator see this GPS when we talk about Braincube, when we talk about RTPO? How does he take advantage of all these benefits?
Great. In the Braincube ecosystem, we have various ways to customize this GPS. I think it's equivalent to you having a Google Maps or a Waze, whichever you prefer to use. But we always start with a standard platform, very streamlined, focused on guiding the operator. They are basically like clocks indicating which parameters you need to adjust now, where you are, and what the ideal window is for that moment.
Oh, something very dynamic that I just, as the process changes, in effect, I think in the next example, I have a screenshot of this screen that I can point out there.
Good. So instead of being paths, actually, it shows exactly the set point to which value it has to.
It goes even further. It shows what the operational window is, right? We really try to move away from fixed set points and instead give the operator autonomy to maneuver there, equivalent to turn right, right?
Cool.
So to wrap up, I brought here an example of another client of ours in the mining sector, one of the largest gold producers in the world, located in Canada, and they were facing a very challenging situation where they needed to increase the processing rate in comminution.
They're focusing a lot on crushing, grinding.
Yeah, challenge they had was the extremely high complexity of the process itself, with more than 250 variables interacting simultaneously. Combined with the complexity of the conditions, there was a very large impact from the change
of the mining fronts and some environmental issues also impacting how they were able to operate in comminution. The engineers knew there was room for improvement. They were already implementing several of those points I showed earlier in the presentation. There was a level of excellence in dashboard monitoring of the process, but the process was changing much faster than they were able to react.
And that was directly impacting the company's actual corporate indicators. So
that's when Braincube came in to work together with the engineers in this process.
So I brought here a summary with the pillars of how it was acted there with this client.
First, product clones. Product clone is a digital environment that replicates the procedural reality in comminution. It captures uncontrollable conditions like ore hardness, feed variability, wear, coating, and also the controllable levers, right? The parameters there that the operator can actually control. The speed of the mill, water flow rate, feed rate, grind size, 250 variables in total. So there is the construction of this model, this product clone. And then we move on to cross-rank AI, right? Which in this case was basically the analysis with more than 250 variables interacting with each other. So the system separates what is uncontrollable from what is controllable. It won't tell the operator to stop the rain. The operator doesn't have that control. And then the system identified within the actual history which set point combinations would allow for highest processing rate in a stable manner, and especially for each condition profile. For each profile that the engineers set as a business rule there, and then varying from the condition of the ore itself or sometimes the environmental condition, the cross-rank AI was able to identify the operating windows for the parameters within those profiles.
Yeah, and we move to the third point, which is the Braincube Live, which is the GPS. It is the GPS screen, in fact, right, Nathan? There's an example below of what, of what was left for the operation there.
Different clients will prefer different types of screens. They prefer this more traditional, more streamlined screen. So Braincube Live is a platform that shows continuous and dynamic prescriptions in real time. It detects which conditions are currently limiting the process. So if it is the hardness, the wear, the classification itself, then it will prescribe the adjustments with the greatest impact for that condition at the moment. And it's important to see that the operator has full autonomy over what to do. The set points, they are updated as there is an effective improvement in the process.
And then the fourth point, which is as important as all the others, is monitoring. So there we have the whole issue of automatic reports in the routine. The idea of Braincube is not to create a routine for Braincube, but to understand how Braincube will fit into the daily life of the operator, the engineer, the manager, providing them with reports and information.
And the main thing is understanding how effective the application of this is. When the operators were following those conditions, did we have a gain in the processing rate? Yes, we did. Wow, let's invest more in understanding why in some conditions they prefer not to follow.
And we have an interesting behavior adjustment, seeing the work of engineers and operators together. They're focusing on the result, right? And in the next slide, I brought some results they had last year in 2025. So $15 million in gains in the year 2025, focusing there on the gains they had through the prescriptions.
And for me, again, I'll go back to stability. For me, it's one of the main indicators. 1.5% increase in the processing rate in the first year. Consistently, right? They identify the clear stability in the process, a standard deviation, a 10% decrease there overall in all the root causes they were identifying in the process.
The operator's reaction time was drastically reduced, going from hours to minutes.
Going back to what we mentioned about the operator needs to be confident that when they act in the process, it will have a positive outcome. If there is doubt, it's like driving on the road without a map, without GPS, you'll go slowly looking at the signs. So that became very evident there. Another point that was important for them was the unification of an operational standard, right? So the behavior of the engineers, the behavior and actions of the operators, the issue of the APC itself that they use there. So the parameterization of the APC follows something more standardized across all shifts and moves away from that issue of, oh, in my shift, it's different. My perception is different, like, right?
So I brought my next slide is a provocative question for you to write in the chat or reflect on during the day. If you achieved 1% to 2% more in the processing rate or 1% to 2% more in metallurgical recovery, what would be the impact on EBITDA?
Because I'm type, the answer is, yeah, there will be some impact. So this means there is some variability that we are not addressing at the moment. There is potential there, money on the table that has the potential to be gained.
So that's it. My final point is that we have two choices: either continue driving without a map or turn on the GPS and get there faster, right? The technology exists, the numbers prove it, and the time for us to start is today.
Perfect. Thank you very much, Raphael. Shall we go to the questions? Folks, we are going to select some questions here that we saw in the chat.
Let's go.
Claudia's question: GPS is the essential tool to follow the correct path, but today there is much talk about autonomous driving, meaning the car operates on autopilot. Is it possible to integrate RTPO with software that has this focus? How would this integration be? Bel, como
Perfect. Great. Yes, great question. And it's a question and a concern that we encounter a lot with our clients today, right? So there are several closed loop systems, and I think the main point is to understand what the integration of Braincube is.
Point one, Braincube fits into the current layer of technology you have. It fits into the, and when we are talking about this AVEVA ecosystem, it is a seamless integration. If you are already using a history, some tool like this, Braincube already comes in to collect data in a standard way.
And the output too, right? So our entire IoT platform itself has an API to communicate with autonomous systems, whichever you are using. This year is a very important year for us. We are entering with all this AI integration, creating the MCP there for you to use for those who use cloud or ChatGPT or Gemini. So the MCP of Braincube is already ready. It's even running with some clients. And the point is, there are autonomous cars, there is Tesla, there is... And then it will depend on how sensor equipped your process is and how much you blindly trust to raise your hand and let the car drive. Yeah, Braincube integrates with that. And we focus a lot on the layer that will be there. Yeah. Even in an autonomous car, you will have the driver, the passenger, someone to act on some condition on the road that the system is not able to see. Like in this one, so in response to Claudio's question, the RTPO was built together with Braincube to integrate both input and output for any system you have nowadays.
Perfect. Thank you. Let's move on to the next one. Question from Benjamin. In ways we can choose routes with less time, shorter distance, or avoid tolls, for example. What types of KPIs can the Braincube RTPO system aim for? Does it consider constraints?
Perfect. That is the essence of our cross-rank AI. So if anyone in the audience already uses Braincube, they will really relate to this in that moment when you are building the model, building the analysis model of cross-rank. The input from the analysts engineering is extremely important to bring in those factors that Benjamin mentioned. What are the constraints I am facing today?
Yes, multi-objectives. I want to increase my production, but I cannot spend so much energy or break this into different rules at a certain time of the month. I have a limit on particulate emissions in a certain part of my process, so I need to respect a condition, a different process constraint. So for me, this is really the basis of how the cross-rank operates.
Perfect. Another question I looked at here. Does Braincube work for other segments?
All the segments, I would say all industrial segments that have data, right, and not necessarily a very high data maturity. I think having, if you have a process that collects data and a team working to improve the process, there's a perfect fit.
I think even the first slide of the presentation, where there was the example of some clients we have, from mining clients, food clients, tire clients. And I would say that probably everyone in the audience is using or has something at home that went through Braincube's optimization at some point in the production chain.
Perfect. Thank you very much. Well, thank you very much, Rafael. Thank you for your participation. Oops! Hold on. It's back here. There was a small drop here, but we're just checking to see if everything is okay, folks. Don't forget to participate in the giveaway. Take a screenshot of our webinar to join us at the end. In case you missed any moment, you can go back here on YouTube, take a screenshot of our screen here and put it in your post. I will now put up our webinar rules, our giveaway rules again. Well, once again, thank you very much for your participation, Rafael. I will bring up our giveaway presentation here. Thank you very much.
Thank you, Nathan. Thank you, everyone.